Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So in previous sessions, we are discussed about engineering tribology subject. So what is the importance of this engineering tribology, and then various topics involved in this tribology like friction, wear, and lubrication, corrosion, and engineering materials also we have studied. So now today we will see some questions, question bank on polymers topic. So how they will ask in the examinations questions on this topic, the polymers topic. The polymers topic comes under this engineering materials. So in previous sessions already we have studied definitions and terminology related to this engineering materials. So now I have taken the topic is polymers. So the important questions we will see the questions and discussions. The topic is polymers. So in first one is define polymerization. Explain the types of polymerization with the example. So sometimes they will ask, so not only the definition of polymers and how many types of polymers. So not like that. They will ask what is the process at the back end of this polymers material. So that process is called as polymerization. So example here shown styrene and polystyrene. The polymerization is a process through which a large number of monomer molecules react together to form a polymer. So here the monomers, so two or more monomers, the large number of monomers molecules combined together to form a big polymer. So that is process is called as polymerization. So the example styrene. The styrene is one monomer. So it is a large number of monomer molecules react together with one molecule, one styrene, one monomer to another monomer like this. So finally, how the output product is polystyrene. The polymer is a substance that is made up of very large molecules that are in turn made up of many repeating units called monomers. The polymerization is the process through which these monomers comes together to form the macromolecules that constitute polymers. The process through which these monomers comes together to form the macromolecules. So then only it will be possible constituted as polymers. The example shown here, the polymerization, the process is polymerization. The styrene formed this polystyrene. Based on synthesis, polymers have been broadly classified into two types. So polymers are now classified to one is addition polymerization. So that is chain growth polymerization. In this, you can see the addition polymers are formed by adding monomer units without any loss of atoms or groups. So in this, the main advantage is during the addition of polymers, it will be formed by adding monomer units to another monomer without any loss of atoms or groups. There is no loss. These polymers formed by the polymerization of monomers containing double or triple bonds. So these are called as unsaturated compounds. See example here shown ethylene. Ethylene is a monomer formed as polyethylene after a combination of two or more than two ethylene monomers. So in this there is no loss. The CH2 here given the chemical equation here, NCH2 and CH2 here carbon 2 and hydrogen 4 molecules, and after the formation of polymerization, you can see the N is the number of monomers molecules presented in this polyethylene. Similarly, vinyl chloride also same form like this, polyvinyl chloride. So CH2, CH2, CH and Cl. There is no loss. So this is this phenomenon is called a chain growth polymerization. One is added to another, another is added to third person. This is addition polymerization. See in his example, another example, adipic acid, hexamethylene diamine. So this is one more example for the addition polymerization. So condensation polymerization, sorry, this comes under condensation polymerization. The polymers formed from the functional group of monomers with the elimination of a byproduct and with the formation of a new functional groups are known as condensation. Here, a new formation is you can observe in this in the equation, chemical reaction, the adipic acid and the hexamethyl diamine. So here condensation means the polymers formed from the functional group of monomers. So here the byproducts they will be eliminated with the formation of new one. So this phenomena is called as condensation formation. So you can see nylon fabric, nylon plastic, and nylon rolls in this figure. You can observe. So this entire thing is called as nylon 6,6. Next example, terylene. The terylene is ethylene glycol plus terephthalic acid. Terephthalic acid plus ethylene glycol gives this decron. With the elimination of byproducts and new things will be formed. Next question is explain the preparation properties and engineering applications of phenyl formaldehyde resins. So how do you prepare this material, and then what are the properties and applications, engineering applications? Bakelite or phenolic resin. It is obtained by the condensation polymerization of phenol and formaldehyde. So already I told you in previous slide, the polymers are divided into the many to other further classification classified. So these are, one is addition polymerization, and another one is condensation polymerization. So in this the bakelite comes under this category, condensation process polymerization. The phenol and formaldehyde in the presence of acid or alkali catalyst. The preparation is, the reaction involves the following three steps. One is step 1. The first step is the reaction between phenol and formaldehyde forms ortho-hydroxymethylphenol, para-hydroxymethylphenol. So these two things finally the formed material. One is phenol plus formaldehyde gives ortho-hydroxymethylphenol plus para-hydroxymethylphenol. So hydroxybenzyl alcohols, these two are called as the hydroxybenzyl alcohols. So this material is called as bakelite or phenolic resin. Generally, this material generally used in electrical switches. So when orthohydroxymethyl phenols are heated with excess of phenol in the presence of acid catalyst to form novolax. So the backlight comes under thermosetting plastics. So in this, once heated this material, it will not regain its original formation. So the due to this the presence of catalyst, so the excess of phenol in the presence of acid catalyst. Here you can see monomethyl phenol plus phenol and gives this novolac formation. Step 3 is further heating of novolac resins in the presence of a curing agent. You keep on heating this material in presence of curing agent, hexamethyl methylene terraneamine is produces. This curing agent is called as this material hexamethylene terraneamine. So produces a hard, rigid, insoluble, cross-linked polymer called bakelite. So the final formation of bakelite is you can write like this. Just what are the properties of bakelite? So the bakelite is a thermoset or thermosetting plastic. Already I told you. Therefore, when heated, this polymer is malleable and liquefiable. So, however, when it is cooled, it becomes permanently hard and rigid. So, when it is cold, it becomes permanently hard. So, not temporarily. So, that's why this polymer is having that property, malleable property. So, mechanical properties are every material having some mechanical properties like strength, hardness, ductility, malleability. So the creep, and these are all mechanical properties. So this bakelite having this malleable and liquefiable property. It is a non-conductor of electricity, having a dielectric constant of 4.4 to 5.4. So non-conductor. It is not conductor. That's why used in this electrical switches. It is heat resistant and therefore non-flammable. It can withstand a high range of heats. Thus, it functions as a good insulator. It acts as a good insulator. So, one more reason this material is used in for used in electrical switches. So, bakelite is also resistant to any kind of chemical action, and hence it is non-destructive. Resistance to any kind of chemical reaction. It can withstand. There is no change. It can be very easily and quickly molded. The moldings of bakelite are fairly scratch resistant. Usually, it has a brown or a amber color. The color of the bakelite is brown or amber. However, it can be found in a variety of colors also. Bakelite has a distinctive sickly sweet or fishy odor. So these are the properties of bakelite material. So in the examination, they will ask question, what are the properties of bakelite? Write some properties. Then you have to write 6 or 5 points. So next one is uses of bakelite. So it acts as a good insulator. So that's why used in the making of switches. Therefore, it is widely used in making several electrical devices like sockets, automobile distribution caps, switches, and insulation wiring, etc. So, wherever heat resistance is required, and there this this backlight act as a good insulator. It is also used in making the non-conducting parts of and telephones also. Radios and telephones. Here shown the backlight has multiple uses suitable for laboratory and DIY. So for the electrical switches and combs, these all are backlight materials. So backlight can be very easily molded. Thus, it can be used for making a variety of daily use commodities like clocks, toys, dominoes, chess, and poker chips, mahjong sets, and washing machine impellers, buttons, kitchenwares, etc. These all are uses of backlight. Since the backlight is available in a variety of colors, it is also utilized for making artificial jewelry like bangles, earrings, and bracelets. It is also widely used as adhesives or binding agents and as varnishes or protective coatings. It is also widely used as adhesives. It is also used in making musical instruments like saxophones, a whistle, and then electric guitar. So these are the uses of backlight material. So this material available in a variety of colors. So that's why it is used in the making artificial jewelries like bangles and earrings, bracelets. These are all items made with this material. And one more advantage uses of this material is it is a purely non-conducting material and also good insulator. Next one is what are biodegradable polymers? Explain with the preparation of biodegradable polymers with its applications. So the biodegradable polymers, generally polymers do not undergo biodegradation even after a long time. It is very difficult to manage the polymer waste in the environment. Nowadays, we are facing this problem. To avoid this, biodegradable polymers are used. They degrade quickly and do not cause such environmental problems. So that's why these biodegradable polymers are very need to save the environmental kind of problems. So the definition is biodegradable polymers are polymers which undergo degradation by the naturally occurring microorganisms like algae, fungi, and bacteria. So this definition related to this biodegradable polymers and applications also we have seen. So polylactic acid or polylactide, you can call this PLA. It is derived from renewable sources such as starch, sugar cane, etc. Polylactic acid (PLA) is a biodegradable and bioactive thermoplastic polymer that has gained significant attention as an environmentally friendly alternative to traditional plastics. So it is commonly used to variety of applications due to its biodegradability, biocompatibility, and renewable origin. So the preparation is it is prepared by the catalytic dimerization of lactic acid and resulting in the formation of lactide monomer. The polymerization of lactide monomer in presence of stannous octide to give polylactic acid. So here you can see the formation of polylactic acid and cyclic lactate monomer. So first the lactic acid to it gives with the action of water cyclic lactide monomer, and then finally form the polylactic acid. So properties of polylactic acid. The PLA exhibits a range of properties that make it suitable for various applications. So the properties, the first one is biodegradability. The PLA is biodegradable under the right conditions, making it an environmentally friendly material. And biocompatibility, it is safe for use in medical and food contact applications due to its biocompatibility. And transparent property having this PLA. So PLA is transparent and can be made into clear glossy products. Next one is renewable source. The PLA is derived from renewable sources such as corn starch and or sugarcane. And rigidity. It offers good rigidity and can be engineered to be similar in strength to conventional plastics. Next, heat resistance. PLA has moderate heat resistance, but it may deform at relatively low temperatures, limiting its use in high temperature applications. Brittleness. PLA can be somewhat brittle, which can affect its use in applications requiring impact resistance. Barrier properties. It has a reasonable barrier properties against moisture and gases. These are the important properties of polylactic acid. So, what are the uses of polylactic acid? So, here shown diagram the uses of polylactic acid by the finds application in various industries due to its unique properties. Packaging. PLA is used for producing biodegradable and compatible compostable packing materials such as disposal cups, foods, containers, and films. So you can see in disposal spoons and the materials and glasses. So and then textiles. In textiles, fibers are used in textile industry to produce biodegradable and sustainable fabrics. And medical and healthcare. So PLA is used in medical devices such as stretchers and tissue engineering scaffolds and drug delivery systems due to its biocompatibility. So 3D printing. PLA is a popular material for 3D printing due to its ease of use, biodegradability, and availability in various colors. So filaments. It is used in the manufacture of filaments for a fused decomposition molding. This is a FDM process, fused decomposition molding. So these filaments also the filaments are useful for 3D printers. Biodegradable films means PLA films are used for agricultural applications uh, such as mulch films, as they can be plowed into soil after use. It's disposable tableware. PLA is used to produce disposable plates, bowls, and utensils for single-use applications. So whenever required, the single-use disc applications, use and throw. The consumer goods. PLA can be found in consumer goods like toys, cutlery, and cosmetic packing. So these are uses of polylactic acid material. So next question is, what do you understand about the vulcanization of rubber? Right, the advantage of vulcanization. So rubber, but what is the process behind this rubber? That is vulcanization. So the vulcanization of rubber, it is the process of improving the properties of rubber compound with same chemicals like sulfur, hydrogen sulfide, benzoyl chloride, etc. Most important is addition of sulfur. Vulcanization was discovered by Charles Goodyear in 1839. He observed that when rubber is heated with sulfur at 100 to 140 degrees centigrade, its tensile strength, elasticity, and resistance to swelling are increased termination. So, shown in this diagram, vulcanization of rubber. So, whenever the rubber is heated, natural rubber is heated with sulfur at 100 to 140 degrees centigrade. So, it gives its tensile strength, resistance increase, and resistance to swelling also increase. The sulfur combines chemically at the double bonds in the rubber molecule, bringing about excellent charges in its properties. Example, resistance to changes in temperature, increased elasticity, and tensile strength, durability, and chemical resistance. These are the advantages of vulcanization process. So you can see here vulcanization process. This is the natural rubber chemical formula, and whenever added this sulfur at high temperatures, it gives sulfur cross linkage. It is with high properties, with high properties like tensile strength and resistance to swelling. This process is called vulcanization. The vulcanized rubber after adding this sulfur. So these are the questions we have studied on polymers topic. So these are the references I have taken. You can refer these textbooks for more details. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.